So let's take a look at our graph. Was it warmer at 3 or 9? There's 3, there's 9. 9's higher, right? Okay. Approximately when was it highest?
I would say about 5:45 p.m.
Yeah, just a little before 6, right there, right? And then at 4 o'clock, where was it about the same temperature as 4 o'clock?
About 8
8 p.m. Okay, I'm down with that. Next question was, I got to look at my slide here because you guys have the better slide than I do. Did the temperature change more between 1 and 3 or 3 and 5? Ivy?
1 and 3.
Yeah, 1 and 3. It was about a half degree more than between 3 and 4. Yeah. Okay, and then the next question was, is temperature a function of time or is time a function of temperature? Chapman? I saw you raising your hand, so I was going to. What do you think? Back there. Oh. So does the time change the temperature? Does the temperature change the time is really what that's asking. What's a function of what? Benny?
Time changes the temperature.
Yeah, time changes the temperature. Okay, let's look at the input 8. When we input 8, what's the output? 57. All right. So we still know how to look at graphs. So looking between 99 and 2000, did it increase or decrease? Increase. We're looking like right there, right? I'm just going to do INC for shorthand. Did it increase or decrease between 05 and 2009? 05, 2005 and 2009.
I'd say it would decrease.
Started here, ended here. So I would also say decrease. So how did it change from 95 to 2000? Who thinks they can tell me? How did it change from 95 to 2000? Sean?
96 was decreased, and then all the rest of the years were increased.
Yeah, decrease 1 year maybe. Then increase for 4. Something like that. And you could have been really specific. Some people maybe said like how much it increased or decreased by.
That's what I said.
That's even more detailed. That's great. Okay? So this is a representation of a function, okay? I'm seeing two types. Man, I'm having trouble with this. 2 types of graphs. I'm seeing someone like this, almost. So what I'm asking is, what is this dip?
Yeah. No, it doesn't. Immediately takes out.
Yeah,
Is it his hand?
Yeah, his hand pushes it out. And then, wait.
Okay, so let's make sure our variables are good. I think the variable is like time in weeks for my dependent, and then I was thinking total money for my independent. So if it dips down, what's happening to the money in the jar from week like 1 to 2? So if it dips down, it means he's losing money. So that's why I was wondering if you change the variable to like the hand going in or something. So here's the number 1 wrong answer that I see. Something like this. And there's a lot of those out there.
Oh, that's what I did.
Yeah, I love this wrong answer. It's the bomb. Because here's why. What this says is,
It's not a function.
well, this is a function, but what this says is weeks 1, 2, 3, 4. That between week 1 and 2, it's growing during the week. But what's happening each week? Is it like growing throughout the week?
No.
Is he having every little penny between 2 amounts? No, all of a sudden there's just more in there. Right?
So there's no dot.
So check this out. This is a really cool function. So I'm going to assume that he starts with some money. Or she, did he give us 100? Okay? And so for the first week, there's that much money.
Oh.
At 1 week,
Oh.
more money in there for that week. The next week, more money. The next week, was it more money? And then less money. Now notice, I'm trying to make this so that these kind of like overlap. Do you guys see? Not overlap, but just barely touch. And the reason for that is he's just dropping chunks of more money in there every week. But then for the whole week, it's staying there. It's not changing. So this is called a piecewise function, okay? Yeah, it's kind of cool. Now, it could be a cool looking graph if you just like got a bunch of pennies and salt bathed them in there, and then it like a little bit for a little moment of time. But there's no way to connect these because there's just a chunk of money in there extra over and over. Right? Are you guys seeing the difference? Do you see why it's good if you drew the one I said wasn't good?
Yes.
Yeah, you made a good mistake and you learned something. That's awesome.
I fixed mine.
Good mistakes are the bomb. Let me tell you about this bike riding situation. I myself, there's like 3 different things I could come up with. The first thing I was thinking was something like rides there, chills there. Then what did he do? Did he go home next?
Yeah.
Home.
That's what we did.
Then he rides to the park, chills there, comes home.
Wait,
It doesn't say he chilled at the park. I'm assuming he chilled at the park because what kind of kid just like rides their bike to the park and immediately leaves? But we could have discussion about things being pointy right here. And this would be time and then distance from home, okay? That would work. Now, I came...
And then did it like this, like the.
So you did distance from the park where you went to home
No.
or something like this?
I did distance from home at the x-axis, and then the time at the y, and then I basically just did what you did.
Okay, but I like what you're saying. So what you're saying is that, so you said distance from home here, right? And time here. You're saying that the distance from home changed the time. But the time would change this, yeah. So we got to get the independent and dependent variables switch there, right? Distance should be a function of time. But it's a similar representation. The other one I came up with was like something like, I won't do the whole thing, but total distance. Anybody do total distance? To time. Because whether he's going to or from somewhere, it's more distance. So that could be another graph. There's also, you could do one distance from park. But it's like it wouldn't make crazy sense. Why would you want to represent that? But could have. Cool. So, question 1, which city was warmer at 4? So, city A at 4 o'clock was how warm? Just over 57. You guys got that?
57 actually.
Yeah, and B at 4 was 62. So everybody got A was warmer? Is that right?
Yeah.
Let's check it out. At 4 p.m.
It's B's.
Let's see. 62, let's go back.
D is cool.
At 4, 57. So it's about 5 degrees warmer, city B. Okay. I'm flipping back and forth. Which city had a bigger change between 1 and 5?
City B.
So A went from here to here. So what is that? About 7. Ooh, 50 between which times again? 1 and 5. So from 58 to 82. It's a lot more. Wow. Let's do it. 24?
23.
23.
Yeah,
Did I get the wrong times? 1 and 5. 58 to 82? That's 24.
It's 59 to 82.
From 5 to 1? Okay, it's 58 to 82. How much greater was the highest for B?
23.
23, there you go. You guys got ahead of me a question there, I think.
Oh.
And then let's check out input 3.
75 minus.
Input 3 on this one, 54 and a half. Input 3 on this one.
75.
So here's some cool conversation I had. I went around and asked most people, did you have a favorite one? And a lot of people were vibing with the table.
Yeah.
You get exact answers and it's quick. But my thing would be like, well, what happens if you're between two numbers? Not as easy. And then over here, who was it that talked about the visual? Kai. Kai said, this one you can see the temperature rise and fall. If you wanted to get a quick visual of what the temperature is going to do that day, would you guys agree? This is way easier than this. to just visualize how it rose and fell for the day. That's cool. I like that. You're going to try this one out in your group next. So, question 1. We've got a cube with a side length of 3, which would give us how many? 27. And if I go to my graph and I have a radius of 3, that would give me, I don't know, something like 120. So, is it greater or less than the volume of the sphere? Yeah, it's less than the volume of the sphere. The sphere has more volume. So if a sphere has the same volume as a cube with edge length 5. So if a cube has an edge length 5, what's 5 cubed? 125. And so I'm going to go over here. 125 is right there. That gives me a radius of about, I'm going to say 3.1. Do you see how I found that using the output? I use the output to find the input. And then compare for input 2. So 2 cubed is 8 for edges, for the edge of a cube. And if I put 2 in for the radius of a sphere, I don't know, like 30, let's just say 31 for fun. Okay? What'd you say, Red? What was yours? Oh, okay. I wasn't just trying to disagree with you. 30's good too. So do you guys see that back and forth? 2 representations. Every representation has a place. I thought this one was easier to throw side lengths into. What do you guys think?
Yeah.
This one's kind of nice to see how that volume changes, like how it changes.
I agree.
It's like, ooh, yeah, that's cool.